Hey kids, welcome to section 4.1 operations with polynomials. Today you're going to learn how to multiply, divide, and simplify monomials and expressions involving powers. And you're also going to learn how to add, subtract, and multiply polynomials. So, there are many properties of exponents that are useful when trying to simplify polynomials. We're going to learn about the major ones today. The first one is called the product of powers. And that one says that you're multiplying two powers together that have the same base. So if you're doing x to the a power times x to the b power, you're going to add the exponents together and get x to the a plus b. Second rule is called the quotient of powers. So we are dividing two like-based powers. So x to the a divided by x to the b, that's x to the a minus b. Also assuming that the denominator does not equal 0, otherwise the fraction would not exist. The third rule has to do with negative exponents. Negative exponents are never allowed. And so if you have x to the negative a power, you can take the reciprocal of the fraction and put x to the a on the bottom and make it positive, and then put the 1 on top. It's kind of like there was a 1 here and you flip the fraction. Same thing if the negative starts in the denominator, you can move it to the top of the fraction and make it positive. The fourth rule is called power of a power. So we're taking something that is being raised to a power and raising it to another power. So x to the a is being raised to the b power. You multiply the exponents together and get x to the a times b. The fifth rule is called the power of a product. So we have some product being taken to a power. So we have a product xy being raised to the a power. Well, you share the power to each of the items in the product. So x to the a, y to the a. The sixth rule is called power of a quotient. This one says that if you have some quotient that you're taking to a power, such as x over y to the a power, you can do x to the a power over y to the a power. And essentially, you're sharing the power. And finally, the last rule is about zero powers. Anytime you have anything to the zero power, it always equals 1. Always. Number, letter, combination, anything to the zero power equals 1. All right, so when we simplify monomials, we have to know if we are done. Remember that a monomial can be a number like 7, a variable like q, and an expression that is the product of one or more variables with non-negative integer exponents, like negative 4x to the third. When simplifying a monomial, we have to check to see if 4 conditions have been met. Make sure that there are no powers of powers. Make sure that each base appears exactly once. All fractions must be in simplest form, and there are no negative exponents. So let's see how we simplify. Simplify each expression, assume that no variable equals 0. If any variable equaled 0, then we might have a 0 in the denominator, and that's not good. Okay, so for letter A here, I'm just going to use the commutative property, which says I can kind of shuffle around the order. And so I'm going to put the number 2 in the beginning, and then I'm going to put my g to the second, g to the negative 1, and then I'm going to put my t to the negative 7, t to the 10th. So I'm just kind of grouping them together. Well, there's no other number that's being multiplied, so I'm going to leave it at 2. And then in terms of my g's, because I am multiplying two powers together, I add the exponents, and this gives me g to the first. And then the t's, I do the same thing. Since I have t to the negative 7 times t to the 10th, I add them together and get t to the third. Now I don't have to have that 1 there, So if I just want to say 2gt cubed, that's perfectly acceptable. Okay, if I'm doing letter B, I notice that I have numbers on the top and the bottom, C's on the top and bottom, and D's on the top and bottom. Well, when I simplify a fraction like this, I'm first going to grab the numbers and do 15 divided by -3. Then I'm going to do C to the power of 5 minus 2, because when I'm dividing two powers, I subtract their exponents. I'm going to do the same thing for D. I'm going to do D to the 3 minus 7. So now 15 divided by -3 is -5. C to the 5 minus 2 is 3. And D to the 3 minus 7 is -4. Now I've simplified all my fractions. My letters only appear once. I don't have any powers of powers, but I do have negative exponents. So I need to make sure that I put the D to the 4th on the bottom and make it positive, and then leave the -5c cubed in the numerator. The only thing that moves is the letter that has the negative exponent. Numbers do not move and become positive, only exponents do. Okay, let's take a look at some more examples. Simplify each expression, assume that no variable equals 0. So letter A, I have a power of a quotient. So I'm going to share the exponent, a to the -3 divided by 4 to the -3. Now, negative exponents are never allowed. So I'm going to move a to the -3 in the denominator and make it positive. And I'm going to move 4 to the 3rd in the numerator and make it positive. And now 4 cubed is 64 over a cubed. Fraction is simplified, no power of powers, no negative exponents, and each letter appears only once. Those are your 4 checks. Okay, in letter B, I have a power of a product, so I'm going to share the power. So I'm going to do -2 to the 5th, x cubed to the 5th, y squared to the 5th. This is going to give me -32, x to the 15th, because when I have a power to a power, I multiply. And then y to the 10th. Again, power to a power, we multiply. All right, if I look at letter D, I've got numbers, I've got x's, I've got y's. I'm going to kind of rearrange, use the commutative property, and kind of put like things near each other. So I'm going to do 2 and -7 next to each other, x -3, x to the 5th, y to the 3rd, y to the -6. So let's see, 2 times -7 is -14. X to the, when I have a power times a power and it's got the same base, I add. So -3 plus 5 is 2. Then I have y to the -3 because I add the 3 and the -6 together. Now I can't leave negative exponents, so I'm going to put that in the bottom of a fraction and make it positive. And then I'm going to leave the -14 x squared in the numerator. Awesome. All right. Letter D, I've got 2 kind of problems in one. I have 2 powers of a product, so I need to share each power with each product. So -1/2 to the -1st, a to the -3rd to the -1st, c squared to the -1st, that's our first quantity. And then we have 1/3 squared, a cubed squared, and c to the 4th squared. Okay, so -1/2 to the -1st power is -2. A to, when I have a power to a power, I multiply and get 3. C to the power to a power, I multiply to get -2. That's the first group. Then I have 1/3 squared, I get 1/9. A to the 3 times 2 is 6. c to the 4 times 2 is 8. Then I need to multiply my numbers together. Negative 2 times 1/9 is negative 2/9. I have a cubed and a to the 6th. I add them together and get a to the 9th. And my c's, c to the negative 2, c to the 8th, I add them together and get c to the 6th. Now, if I want to, I can put this all in one big fraction. The negative 2 goes on top and the 9 goes on the bottom. And then I put a to the 9th, c to the 6th, all in one group. Okay, so that's how we multiply and divide monomials. Let's talk about other operations with things called polynomials. So the degree of a polynomial is the degree of the monomial with the greatest degree. So kids, a polynomial is just a bunch of monomials added and subtracted together. So if you want to find the degree of the entire thing, you find the degree of each of the little things, and then you find the biggest. So determine whether each expression is a polynomial. If it is a polynomial, state the degree of the polynomial. Okay, letter A. This is a polynomial. The degree is 7 because this first term has a degree of 7, this 4 plus 3. The second term has a degree of 5. 7 is greater than 5, so the degree is 7. In letter B, well, I can't have a square root, so this is not a polynomial. Because of the radical. Okay, letter C, x to the negative third plus 2x to the negative 2 plus 6. This is not a polynomial because of the negative exponents. Negative exponents. Okay, letter D, x over y plus 3x squared. Again, this is not a polynomial. You can only have exponents. You can't have exponents in the denominator. No variables in the denominator. No variables in the denominator. Letter E, x to the 5th y plus 9x to the 4th y cubed plus or minus 2xy. This is a polynomial. So to find the degree of the polynomial, we find the degree of each monomial and find the greatest. So x to the 5th y has a degree of 6, 5 plus 1. And the middle term has a degree of 7, 4 plus 3 is 7. And the third term has a degree of 2 because 1 plus 1 is 2. Highest is 7, so that is the degree of the polynomial. All right, let's add and subtract polynomials. When you add and subtract polynomials, you want to find like terms. So in letter A, 4x squared minus 5x plus 6 minus 2x squared plus 3x minus 1. Well, you're going to grab your x squareds. So 4x squared minus 2x squared is 2x squared. Then you're going to take negative 5x minus 3x. That's negative 8x. And then you're going to take 6 minus a negative 1. And that's 6 plus 1 or 7. So when you're adding and subtracting polynomial expressions, all you have to do is look for like terms. Once you find the like terms, pay attention to if it's addition or subtraction, and then find your answer. In letter B, 6x squared minus 7x plus 8 plus negative 4x squared plus 9x minus 5. Find your like terms. I've got 6x squared plus a negative 4x squared. That's 2x squared. I have negative 7x plus 9x. That's 2x. So plus 2x. And then I have 8 plus a negative 5. That's 3. All right, in letter C, pay attention to the subtraction. So I have negative x squared minus x squared. That's negative 2x squared. Then I have negative 3x minus 2x. That's negative 5x. And then I have 4 minus 5. That's negative 1. Okay, last one. This is subtraction. So it looks like this is my only x squared term at the beginning. So I'm just going to drop that down. Not 2, 3x squared. Then it looks like I have this only one single x. So you're minusing a minus x, which is really a plus x. And then you have negative 6 minus 1. That's negative 7. So 3x squared plus x minus 7. Okay, let's use the distributive property. So find the product. Okay, so we have a couple different types of products. We'll do these first, look an awful lot like the distributive property. You have something on the outside and a quantity on the inside, so you have to multiply. So I recommend distributing and writing it each time, but it's up to you if you want to write it or not. So I'm going to do 4/3 x squared times 6x squared plus 4/3 x squared times 9x minus 4/3 x squared times 12. So let's see, 4/3 times 6 is 8. And then I have x squared, that's x to the 2 plus 2 or 4. Plus, and then I have 4/3 times 9, that's 12. And then I have x squared, x to the first, so that's x to the third, minus, and now 4/3 times 12, that's 16x squared. So 8x to the fourth plus 12x cubed minus 16x squared. All right, letter B. So let's distribute negative 2a times negative 3a squared minus 2a times negative 11a minus 2a times 20. So if I distribute, that gives me 6a to the third because it's 1 plus 2 plus, because it's negative 2 times negative 11 is a positive 22. And we have a to the first, that's a to the second, minus 2 times 20 is 40a. All right, for letter C, we're going to distribute 3x. So 3x times 2x squared plus 3x times a negative 4x plus 3x times 6. So if I multiply 3 times 2 is 6, and I add the exponents to get x cubed, I multiply the 3 and the negative 4 to get negative 12, and I add the exponents 1 plus 1 to get 2. And then I multiply 3 times 6 to get 18, and I tag along an x. In letter D, I'm distributing negative 2/5 xy squared. So negative 2/5 xy squared times xy minus 2/5 xy squared times negative 1/2 x minus 2/5 xy squared times y to the fifth. All right, so it looks like I'm left with 2/5 X to the 1 plus 1 is 2. Y to the 2 plus 1 is 3. Minus, well, actually, it's going to be a plus. Negative 2/5 times negative 1/2 is a positive 1/5. And it looks like I have x times x, so x to the second, y to the second. Then I have minus 2/5 x, and then I have y to the second, y to the fifth, so that's y to the seventh. All right. Very good. Okay, we got one more type of distributing. Find the product. Well, now I have a trinomial and a binomial. And then in letter B, a binomial and a trinomial. So when you're doing these, you're going to take each of the things in each of the parentheses and multiply by all the other ones. So first I'm going to distribute x squared. So I'm going to get x squared times x minus 4. Then I'm going to take the 4x and I'm going to multiply. Plus 4x times x minus 4. Then I'm going to take the 16 and multiply. Plus 16 times x minus 4. And then we distribute again. So now we get x to the third minus 4x squared plus 4x squared minus 16x plus 16x and minus 64. Look at this. The negative 4x squared and the plus 4x squared go away. The negative 16x and the plus 16x, those go away. I'm left with x cubed, and I'm left with minus 64. All right, last problem. We've got a binomial and a trinomial. So let's take the 3x and multiply it by everything. 3x times 2x squared minus 4xy plus 5y cubed. And let's do minus y times 2x squared minus 2x squared minus 4xy plus 5y cubed. All right, so distribute. That gives me 6x cubed minus 12x squared y plus 15xy cubed. Then distribute the y. Minus 2x squared y plus 4xy squared minus 5y to the fourth. So now let's see, do we have any like terms? Looks like I have an x squared y here and an x squared y here. So we shall say 6x cubed minus 14x squared y. Then I don't have any more. Plus 15xy cubed plus 4xy squared minus 5y to the fourth. Well, that one's just pretty ugly, but not impossible. All right, kids, that's the end of section 4.1. If you have any questions, please let me know. And as always, keep calm and keep trucking.